So how have you been?
I've been all right. Sorry for the delay.
Okay, it's all right. It's all right. Yeah. All right. So is my voice clear for you?
Uh,
Is my voice clear?
yes, it
Okay.
is
Okay.
clear.
All right. Yeah. Right now,
Yes.
my kids are back for the winter vacation. So
Oh, okay.
yeah, but it's fine. Yeah. Hold on. All
Nice.
right. So
Okay.
let's. So how have you been this weekend?
Yeah, I'm all right. It's a bit hectic because
Okay.
I moved to the new place over the weekend. A place close
I
to
see.
Stellenbosch, so it was
Okay.
a bit
Nice. Nice. Okay.
intense, but
All right. All right. Good. Good. I can
yes.
see that from your background. It's changed.
Oh
Yeah.
yeah,
And
the
also
background
it's
looks
brighter. It's brighter.
yes.
Okay.
Yes, it
All
is.
right. So is Herman going to join us today? Do you know?
No, remember he said I think they have like a committee meeting or a staff meeting or something
Oh
like that.
yes, yes, on Tuesday. All right, sure. All right. So let's start then. All right.
All right.
Okay. So
Just share.
yeah, please yeah, I can see that you have a lot of progress last week. It's
Yes, I was
okay.
momentum is very important.
And yes, yes, it is. It is.
Momentum. But
I might turn off my video. Okay, so
no,
to
that's
have
fine. Let me switch off mine as well just
all right.
for
Okay.
better
So yeah. So
bandwidth.
please share about what has happened so far. Yeah.
All right. So if you remember, I spoke with Hammond on Professor Hammond, sorry, on Friday, right? So basically, what I did, and again, forgive my drawing because it's horrible. I'm still looking for a tool that can do this better. But the idea was,
Okay.
okay, say we have a simple Verona, network like this, with all these nodes connected to each other.
Right.
What would happen, right? Say you want to send data to what would happen on each node. Sorry, that was the idea. Now,
Okay.
after speaking with Herman on Friday, it turns out the the existing vast library already does all of that. The
Okay.
idea was
Okay.
to say pub init, like initialize the publishing mode, or the publish mode on each node, to first create a data structure and create the topic or channels, how it's gonna send data, and then post the ID, the node ID. Oh yes, if you notice, there's like two IDs here. So the idea behind this was maybe one is, I don't know, for someone said, usually the ID has all the information, including IP and
Mhm.
like metadata, for example. So the idea was to have, this data structure have all this information, the coordinates, the subscription status. Now, if you notice, this IDTF basically means identification. So the idea is when every node starts, there's a channel for identification. There's also a channel for friends, like the neighbors, and that's
Okay.
what this is, right? So the idea is post sort of suggests publish. I know there's probably better ways to express
Oh,
that,
it's
but that was
fine.
just
Right.
for
Right now, it's just the concept. It's more important.
concept. Yeah. So once, so again, this is what by default it happens. Like say if we switch on the system, this is how each node should behave on start, right? And also the get request. So this is more like the subscribe sort of mode where we're saying, okay, first, so this get request, these are all the requests under, this is like a sub process. And these are all the things that fall under that. So the
Mhm.
idea is, get the neighbor list, get the neighbor ID, get the neighbor IP, get the status, whether it's subscribed or unsubscribed,
Okay.
get the area of interest. Basically, all that information sort of goes in. But then, like I said, it was basically saying this already happens on the Von layer. I mean, sorry, on the vast library, and also it did suggest that the network can handle quite a lot of requests at once, because there was also the concern of what if 1,000 nodes are, querying the Von network or the Von layer at the same time? Will they be
Okay,
able to
right.
handle? And it did say that, yeah, it's quite robust in itself. So this was not necessarily, what's the word? It's not really necessary if it already exists.
Okay.
If that makes sense. So the
Okay.
idea was what we now agreed on was that I would create like a bit of pseudocode based on, now that we have this. If I wanted to route it, send information from C to E or C to D,
Okay.
what would I
Right.
do? Right? Like, how would we, or if I wanted to send from C to A. So basically the idea is, now that's where the modes come in. Like, if the nodes are enclosing neighbors, what's the process that should follow that? If it's, for example, you have E and you want to send to, I don't know, sorry, you want to send to C, how would I do that? Right? That's where
Okay. I
the
see.
estimating, the shortest route. And anyways, but the idea is that's where all these sub processes now sort of come in for each node. So it now suggested that in the future, after getting this right, that's when we can now think about, optimizing the route. Or for example, if there was like an obstruction between C and B, then, but that's like future work now. Well, not necessarily future, we're going to do it, but the idea is, in the meantime, how do we achieve this? So the idea is I try to create a bit of a pseudocode. uh, sorry, my pseudocode is not, I don't know if it's industry standard. It's sort of a mix between, I don't know if you can see this. Maybe I should zoom that a bit.
Okay. Okay. Yes.
Um,
Larger is better. Yes.
yes.
Okay. I can see it now. Thanks.
Yeah. So basically, yes. So if network status, so this is under the assumption that this is already done. So under that, now the idea is get node ID, for example. So I used a bit some of my variables. I also used some of the variables you used from your thesis.
Okay.
And the idea is, okay. Yes, I wanted to confirm about this. I don't know if there is already a mechanism to check if the system is online or
Okay.
system is active. But if the Von network is already activated and it's running, then the idea is to start all of this, or
Okay.
else, basically wait like a short period. And if this is elapsed, basically say timeout error, right? And then sort of end the whole process.
Okay. Okay. So that
So
is
now,
initialization hasn't finished in time.
y-
Is that right?
so yes, if the initialization is not okay after
Okay.
300
I see.
milliseconds,
It
yeah,
time out. It times out.
then
Yeah.
timeouts basically, yeah, it basically times out. Maybe I should have put timeout alone, but
Okay.
anyway. So the idea then is, now if it's okay, then basically this, all of this is in a while loop, including that. The idea, it sort of keeps executing, but in this while loop there's like a for loop. Again, this is still a bit fuzzy. I'm not really sure if
Okay.
that's the approach, but this is just standard C programming mode.
Okay.
But
It's
the
fine.
idea
It's
is,
pseudocode. Yeah.
yeah, so yeah, the idea is we want to know what our ID is, want to know what the AOI is, and then want to, know what our neighbors are, and that's what all these variables are. So, for example, say we want to send a packet to a neighbor. This is not necessarily important. I just put that there for me to understand it, for
Okay. Sure.
ease of reference for myself. But so, I do remember seeing some sort of query nodes, right? I want to query now the existing node now, and then to check if the ID knows the neighbors, or should I say, if the neighbors are known. Basically, that's sort of what this is
Okay.
trying to
Okay.
say. If the neighbors are known, right, and also the boundary neighbors are known, because I do remember seeing that in your thesis as well. Then just send it to the message. Like so
Okay.
basically it's
Okay.
two
Right.
conditions there. That if it's in the boundary, if it knows the neighbor, if it's on the, what do you call it? How do I put it now? Let me see if I can point it out here. So the idea is if they share, if C knows B, and it's also in the region of C, if that
Mhm.
makes sense, or in the
Okay.
area
Okay.
of
Right.
C, then send message. Else, get closest. Now remember, this is also this is a, I think, I don't know if it's a function, or I think it's a function
Mhm.
in the
Okay. Okay.
existing
You
vast
can think of it
library.
as a function. Yes. Mhm.
Yes, yes, that sort of gets the enclosing neighbor, and then the idea is once you get it, then you just send the message. Oh, geez, I
Okay.
didn't
Okay.
put that.
So the enclosing neighbor.
Send, yeah, send message. All right. Now this is not. Let me just comment that out for now. This is not. I have a feeling this is supposed to sort of come in somewhere before here,
Okay. Okay. Mm-hmm.
but I'm still trying to figure out that do the channels already exist,
Mm-hmm.
or
Okay.
does the node create new channels?
Okay.
If that
Okay.
makes
That's a good
sense, I don't.
question. Okay.
Um,
All right.
uh, and then more or less the same thing with the subscribe mode. Get the ID, get the AOI, get all this information, and then check. What's the word now? Not AN, sorry, EN. Check the enclosing neighbors and check the BN. Which is okay. I don't think this thing updated. Sorry, this information is on my PC. And
Okay.
my PC does not have internet yet. I'm still waiting for my Wi-Fi. I thought
Okay.
I uploaded, but it's more or less the same approach. The idea is if it contains the channel, then send the message, right? No, what's the word? Yeah, send the message to the enclosing neighbor, right?
Uh-huh.
That's
Okay.
if it's in the same. I mean, sorry, not send the same message. Check the channel on each boundary on if for each neighbor, and then um, see if it has the channel I'm looking for, if it has the message I'm looking for. If not, also get the closest, the node, the closest node that has the information. Now, the big
Okay.
question behind all of this now that I think it's a big, okay, it's not a big problem, but in your master's thesis, there was a
Right.
part where you talked about how the 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 neighbors are not sent to the
Okay.
to the neighbor information, sorry, or the neighbor's
Right.
data is
Right.
not sent, just the ID and the position and the AOI is sent,
Mm-hmm.
and
Okay.
this is to conserve bandwidth.
Mm,
Now I
right.
don't know if this was just for your thesis or for the vast library itself.
Okay. Okay. Right. Basically, if information is not needed, then we try to make it minimal. Basically,
Okay.
that's the principle.
Okay.
I cannot answer
Okay.
that right now because implementation is, being a while. But I would suspect it basically follows what was described in the thesis. Okay.
Okay.
All right.
Okay. Okay.
Okay.
No.
So anything else so far?
Yeah, that's more or less. And I remember I had to most of the other stuff I sort of showed.
Okay. It Okay, it's fine.
Uh,
It's fine. Good. I think
okay.
it's very good. Okay. To the good being that you have already gotten to a pseudocode. Okay, and get the
Okay.
procedures and the steps down on paper. So this will help you to think. Okay. Okay. This is
Yeah.
definitely very. I think good positive progress. Okay. So what is your biggest question now? I mean, what's the biggest thing that you don't feel quite understand or grasp, or you like to like you feel
So
this is like the biggest obstacle? Yeah.
So I wouldn't call it, I don't know if it's an obstacle. I think it's more of the thinking process now in terms of, because I have the big picture. The big picture is clear.
Okay.
I
Okay. All
know
right.
what we're
Okay.
trying to accomplish.
I see.
Um,
Okay.
the question
S-
is now the approach on paper,
Right. Right.
or should I
Exactly.
say the
How do
detail?
you get to the details? How do you get it into execution? Right.
Exactly. Yeah,
Okay.
that's
Okay. All right.
s- so.
Okay.
Before I go to the computer or before I start my notes, I already have this big picture in mind. But now when I go to the paper and I'm like, okay,
Okay.
um,
What should I do? Is
what?
that it?
Yeah,
Okay.
and it
Okay.
sort
All
of
right. All right.
comes
Okay.
in
All right. All right.
waves.
I see. All right. Okay. Let me answer your questions. This is also, I think, one of today's main feedback. Okay.
Okay.
Which is, I mean, I can share with you how I do things or how I did it. Okay.
Okay. Yes.
Which is,
That would
I
be fine.
actually start with data structure. Okay.
Data structure.
Data structure. Yes. Yes.
Okay.
So the idea behind starting with data structure, well, basically you have to understand there are two parts you have to design. One
Yeah.
is the data structure, which is essentially how you encode the information that is going to be transmitted over the network. Okay, to build our overlays, to transmit message, to do query,
Mhm.
to update, to do everything else, right? But you have to do this through some kind of data structure. Okay, is that
Yes.
understandable? Yeah, is that clear?
Yes.
This is important idea. Basically, you have data structure, and then you have the process or procedures or algorithms, right? That
Yeah.
handles those data structure, computes on them, change the data, collect data, so that you can execute and perform the desired tasks, which in our case is one to maintain a fully connected overlay network, right?
Mm.
That's the peer-to-peer
Yeah.
part, right? And
Yeah.
second, to support spatial PubSub functions on top of that,
Yeah.
right? Okay.
Yeah.
So this is achieved mainly through data structure. In my work, I call it procedures.
Okay.
Okay. I mean, but it's the same. I mean, just you can put it different names: process, procedures, algorithm. But essentially, the step-by-step process, right? That
Yeah.
executes so that things happen, right? And
Yeah.
when you think about data structure, you also have to note that there are two aspects to this. One is the data structure you keep in memory. Okay.
Okay.
So that's the part where each process, when executed, you will have access to these data structures, read data,
Mm.
and then manipulate them, right? And then maybe store
Yeah.
back, right? And sometimes even to database, but that is beyond our current scope. We don't have to worry about that, okay, for now.
Okay.
Okay. Just you can treat it as just in memory data, okay? And then there's the data that you have to send over the network, right? In order to synchronize things. Make sense?
Mhm. Yeah.
Okay.
Yeah.
So you can think of, I mean, this is, I guess, another important core concept about distributed systems. You can think of a distributed systems, like a peer-to-peer network or any other kind of distributed database in the sense that, okay, if you imagine there's just infinite resource, like infinite hard drive, infinite memory, you don't have to build distributed systems, right?
Yeah.
Makes sense, right?
Yeah.
Because
Yeah.
you just put everything into one single large memory, right? And
Yeah.
execute everything there, right?
Yeah.
And the whole point of us designing distributed system is the fact that each node has limited resource. Okay.
Yeah.
So they will all carry and keep a partial record of the entire picture or the whole view, the global view, so to speak,
Mm.
of all the data, right? I think
Okay.
that's
Yeah.
understandable, right?
Yeah.
Okay. And how is this being achieved? It's essentially through packets and messages that try to coordinate and synchronize among the different computing nodes. Okay.
Okay. Okay.
All right. So
Yeah.
when you visualize and picture this way, you can see that data structures serve two purposes. One is when they're in memory, right? They are
Yeah.
for calculations sake. You see? So the question you ask is, what is the minimum amount of information that I need in order to carry out a particular task at hand? You see?
Yeah.
Is this making sense?
Yeah. Yeah.
Okay. And the second question with data structure regarding is, what is the amount of message or information I have to send over the network in order to coordinate or maintain a consistent view among these different nodes or computing units, so to speak.
Okay.
Okay.
Basically, to have like a global view.
Does that also make sense?
Yeah.
Okay, because you have distributed nodes, right? They are at different
Yes.
places, and they all have like a partial view of the whole picture, right? Because
Yeah.
we're not God. God knows everything, right? We only have local views, right?
We have
So in order
yeah.
to keep our local views consistent, and why is that so? Because we all have changing states, right? Like if a node
Yes.
moves, if a node like temperature increases, for example, the sensor has new data, right? That is
Yeah.
something that it needs to send over in order to coordinate. But
Yeah.
the point, the purpose behind coordination is to keep things synchronized. You see?
Yeah.
Okay. So
Yeah.
that makes sense, right?
Yeah.
Okay. So now you can think of data structure in these two ways. One is like, how is it going to, what's the minimum to support the algorithm processing, the calculation part, right? And the second is, what's the minimum to send over network so that to keep everything or the relevant parties all consistent, so that they have a shared view that they can calculate the right results.
Okay.
Okay.
Yeah.
So that's the data structure part. Okay.
Yeah.
Is everything understandable so far?
Yes. Sort of like in the, it's like a step by step.
Right, right.
That
And
helps a
the
lot.
reason why
Yeah.
I emphasize data structure is that if you can build your data structure first, you see, then you can start to try to figure out like what are the processes, right, necessary
Yeah.
in order to sort of get to the results we want. And then you can ask yourself the question, is the amount of information I have enough?
Yeah.
You see? And if not enough, that probably means I will need to coordinate with other nodes
Yeah.
to get their information so that I can properly compute what I need to know.
Okay.
Right? For example, like routing, right? Like which node to forward to, whether you already have the logic, okay?
Yeah.
You have the logic of deciding whether you should send directly the message to a node or to forward to the next closest node, right?
Yeah.
Right? I mean, I can see from your pseudocode, you have this logic,
Yeah.
right?
Yeah.
You have the intention to do this,
Yes.
right?
Yeah.
And basically, in order to judge this, you need to have a certain amount of knowledge, right?
So I want to know
Related regarding who your neighbors are, right?
Yeah.
And like
Yeah.
what do we have access to them, for example, right?
Yeah.
Okay, so that's the data structure you need to design.
Okay.
And then you can check your procedures against that data structure to see if it's enough.
Okay.
Okay, make sense?
Yeah.
Okay. All right.
So
So
the
I guess
idea is to. Oh, sorry.
okay. Go ahead. Go ahead. You have some question?
No, I'm just trying to see now. So basically, the idea is to sort of first know what you need,
Exactly.
both on a
Exactly.
global and local perspective.
Well, in a distributed system, it's always local. It's always local.
Local. Okay.
Okay. You see,
Okay.
we don't assume there's global knowledge.
Okay.
That's a centralized system. thinking.
Centralized. Okay.
In distributed system, you always think locally.
Okay.
Okay, you only have
Um,
local knowledge. You have to assume you only have local knowledge, but
so
you have to carry out tasks similar to a system where it has global knowledge. You see,
okay. Okay.
does that make
Okay.
sense?
Yes. Yes.
Okay, you see, because
Yeah.
recall that, remember that. I think I in earlier session I told you about you can just create a spatial PubSub centrally very
Centralized.
quickly,
Yeah.
like over a weekend probably, right?
Yeah.
You can probably do that. Well, in fact, I think for your next assignment, I think why not just do that?
Okay.
Okay. I mean, why not just start with a centralized version, okay, of the pseudocode and data structure? You see?
Okay.
Okay. So maybe start with that. Just design the data structure and the procedures relevant, necessary, okay, to support spatial PubSub centrally. So forget about communication, sending packets, all that. Just assume you have, global knowledge.
Okay.
Right.
Okay.
Build and design a
Okay.
centralized spatial PubSub system first.
Okay.
Okay. And then try to design all the algorithms or procedures and the data structures out.
Okay.
And make sure that it works,
Yeah.
right? But by
Yeah.
working, not implementation. I'm talking about
Yeah.
conceptually it should work.
The concept. Yeah.
You see?
Okay.
Okay. And then we can think about how to decentralize that.
Okay. Okay.
Okay. That does that make
Makes
sense?
sense.
Okay.
Yes.
All right.
Makes
And
sense.
one last thing as a feedback. Can
Yeah.
you open up my master thesis? Do you have that with you?
Yes.
Okay, just open up because there are specific sections I want you to maybe have a look
Okay.
and maybe try to follow the format that is there. Because
Okay.
if you look, I also divide. I mean, I design the work into data structure and procedures. I believe.
Yeah. I remember the procedures, the join, and the
Right,
leave,
right. Exactly.
move. Yeah.
Right. So can you show that? I mean, are you able to open that PDF and share or no?
Oh, oh Lord, I have print version. I know I
Oh,
have
print.
it somewhere.
Then it's fine. Then it's fine. But what I would like
So
to
let me
say
see.
is just study them and maybe just copy
Okay.
them. Okay.
Okay.
You can just start with there. Okay.
Okay.
The data structure, design, and also the procedure, how it's being written and described. Okay.
Okay.
And there are two reasons why I want you to do this. One is that so you can get an understanding of what I'm talking about, separating into data structure and procedures. And
Okay.
secondly, this is a format that was already accepted by academic conferences. Okay.
Okay.
Actually, you can also look at the Vaughan paper, the IEEE network Vaughan paper. I believe there were also, but it's a simplified version of the procedures and data structure, I believe. I think the
Okay.
thesis has the more complete version of the design.
Okay.
And that may be what you need to get started, to do something similar.
All right. Oh, that's
Okay?
fine.
Is
Yeah.
that okay?
That's fine. Thank you.
Okay, you
Sorry.
sound is it okay though? I mean you sound
No,
unsure.
I'm trying. No, I'm just trying to see if I can find the thesis. I know.
Oh, okay, it's fine. I mean,
Someone
just
sort
just
of
do it
sent it to
afterwards.
me.
But did you see you see? There are specific sections I want you to have a look at,
Yeah. Yes.
right?
The
That the
basically
procedures
the
section,
procedures.
and
Yes.
also
Yes.
I think the data structure. I think there is also a part that describes the data structure. Okay. All right.
I
Okay.
see
So
the protocol.
yes. So if you can follow that format, okay, just do something very similar to that, but
Okay.
try to come up for spatial PubSub and in a centralized fashion for now.
Okay.
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 I think that would be a very good step, next step
All right.
forward. Okay. All right. So
That's fine.
is that okay?
Yes.
Is it clear? Well, what I'm
Yes, it is.
asking you to do?
It is clear. I
Okay. Okay.
just
Good.
found
Good.
this now.
Oh yes, 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 yes. Okay, okay. Yeah, that's the PDF. All right.
I don't
Just so
know.
go down to the I think the table of content. The table of content.
Oh,
I
sorry.
think go to there probably should be a table of content somewhere, right?
Yeah,
Like a TOC. Right here.
I
Okay.
think it's three.
So I think that's the system design part. Okay, go to section 3.2, system design.
Yeah.
You see,
Okay.
there's the overview, the join, move,
Yes.
leave, procedure, the form protocol, right?
Yeah.
So
Yes.
3.2 is what you need to have close look. Can you jump to 3.2 now? Let me just
It
like,
doesn't let me click
I
on
think you can
the
just click and
page
we'll jump.
29.
I think you can just click on
I'm.
3.2. No?
It's because I'm using
Oh,
Firefox.
oh, okay,
It's
okay.
not.
I see, I see. Okay, all right. So go to 3.2.
Sorry, forgot the number now.
Ah, see?
Okay, there we go.
Okay, okay.
Yeah.
See? See? Definition.
Yeah.
Yep.
There.
Okay. So 3.2. Yeah. Okay. So scroll down. Okay. So definition and notation for pseudocode. Okay. So this is something you probably will want to write one as well.
Okay.
You see?
Okay.
Okay. And you can copy this, if you like. Okay.
Okay.
And then go down. Okay. So this is just describing, the sort of the definition. Okay. And see, and then there's the procedures, right?
Yep.
Right. Okay. So that's
So
kind
that's
of
the
like
procedures. Yeah.
exactly. That's kind of like what you have written for your flow chart. Okay. It's just listed. I think it's both are fine as long as you can convey the main idea. Just that personally, I find the listing, to be more helpful. But see the one below, that's the pseudocode. Okay, so that's a very simplified, highly tensed version of. I mean, it's you can see that it's very concise, right?
Yeah.
Okay,
Yeah.
so I mean, this is the eventually your paper should have something like this.
Yeah.
Okay,
Yeah.
but we don't have to do that all at once. Okay, just try
Okay.
to understand that this is the kind of maybe the pseudocode that you can create, to describe your procedures or algorithm.
Yeah.
Okay, and then
Yeah.
go down.
Okay.
Uh, yeah, keep going down because I think these are similarly just procedures, and then
Mm.
also the pseudocode, right?
So okay.
Okay,
Yeah.
and then just go down. I want to see the session about the protocol, the VOM protocol.
Okay. I think it's down. Yeah. Yeah.
Yes, here.
Yeah.
You
Yeah.
see? Table 2, that's the data structure. And you can see it's very simple, you see? It's very
Okay.
simple, you see?
Okay. Wow. Position.
Okay,
Okay.
that is what I would like you
Perfect.
to do for spatial PubSub as well. Okay,
Okay.
and you see the VOM protocol. That's the actual messaging to transmit the data structure to synchronize or coordinate, okay, among the different views.
Yeah.
Okay,
Okay. Yeah.
so when you get to this level, it's just one more step to become workable code. Okay,
Okay.
supposedly, any language, PHP, Node, JavaScript, or C Sharp, C++, you can write and implement a VOM protocol just based on this information. I mean, an implementation or a vast library. That's
Yeah.
the goal of this design. You see,
Okay.
like in the end, you should be able to design something that person with any language background can implement a specific version of that based on
Okay.
this document. That's the purpose of the document and the goal of a document, a design document. Does that make sense?
Yeah. Yeah. It does.
Okay, and your paper should basically should produce something like that as output.
Okay.
Okay.
This is helpful.
Okay. Is that helpful?
Thank you. Yes.
Yeah.
Very.
I hope this is a lot more concrete, right? Than
Yes. Yes. It is. It is actually.
okay. All right.
No.
So try to produce. Doesn't matter how much or how little, but try to move towards direction and try to come up with a first draft by Thursday, so we can sync
Okay.
with
Yeah.
Herman. All right.
Yes. Yes.
Okay. All right. So any other questions?
For now, that's
Okay.
all for now.
Good. All right. So get busy then. Okay.
All right.
All right.
Thank
So
you
talk to you on Thursday
very
then.
much.
All right.
Yes.
Okay. So have a great work days ahead. Okay. Yeah. I'll see you on Thursday then.
too.
Okay.
Yes.
Yeah. All right.